Now, what is a hashing? Hashing is a critical process in which a hashing algorithm convert input data such as a string or integers into a fixed size output referred to as a hash code or hash value. This output functions as an index, okay, facilitating the efficient storage and retrieval of the data within an array or hash table. It is initial for the hash function to be a deterministic, ensuring that the same input consistently produce the same output. This technique is frequently employed to create a unique identifiers for data which allow for rapid access to information within a large dataset. For instance, web browsers utilize hashing to securely manage their password. When a user input their password, the browser generates a hash value and verify it against the stored hash value to authenticate the user identity. Okay. Now, how hashing works? Hashing involves three main steps: input, hash function, hash algorithm, output, hash value. Okay, input: initially the data that required hashing is provided to the hash algorithm. Okay, and hash function: subsequently the hashing algorithm process the input data through the mathematical function to generate a fixed size hash value. It is initial for the hash function to be designed in such a way that distinct input value yield unique hash values. Okay. Additionally, even minor modification to the input should result in considerable charge in the output. Okay. Output. Finally, the produced hash value is delivered, serving as an index for the efficient storage or retrieval of data within a data structure. Okay. Now, hashing algorithms. There are many hashing algorithms, each offering unique benefit and throwback. Okay, some of the most commonly used algorithm: MD5, SHA1, SHA256. MD5, a hashing algorithm that is widely utilized and generate a 128 bits hash value. Okay, and SHA1, a well-known hashing algorithm that create a 160 bits hash values, and SHA 256, a more secure hashing algorithm that result in a 256 bit hash value. Now, hashing use cases in cybersecurity. Hashing is an initial component of various cybersecurity algorithms and protocols. It effectively converts sensitive data or text into a value that is extremely difficult to reverse engineer, enhancing data security and integrity. Okay. There are three prevalent use cases of hashing in cybersecurity: password storage, digital signature, file and document management. Password storage. Storing password in plain text within a system, application, or device poses considerable security risk. To mitigate these risks, a robust password storage solution utilizes hashing to encode and securely save login credential as the hashed value. Okay. When users seek to access the system in the future, The solution verify their authenticity by comparing their entered password and against the corresponding hash value stored in the database. Okay. Now, digital signature. A digital signature is a cryptographic method that helps the verify origin, authenticity, and integrity of message, documents, or transaction. To to create a digital signature using hashing. First, a hash function is applied to the original message to generate a secure hash value. Next, the hash value is encrypted within a private key honored by the sender, resulting in the digital signature. The recipient then the user a public key to decrypt the digital signature. After that, the recipient applies the same hash function to the resulting hash value. If the two hash value match, it confirms that the message has not been changed and that it comes from the intended sender. Okay, now file and documents management. Digital signature are widely recognized for their role in securing email and various forms of digital communication. Additionally, they are initial for authenticating and verifying electronic transaction and documents. Okay. There are two key applications of digital signature: documents comparisons and data integrity verification. Document comparison. A document is hashed using a hash function that generates a fixed value string serving as a unique identifier for that document or file. Any modification made to the documents, regardless of size, will result in a change in the hash value. This property enables hashing to function as an efficient and reliable method for comparing files, okay, ensuring their integrity and security. Now, data integrity verification. To maintain the integrity of data within a file or documents, a hashing algorithm generates a checksum, which is a hash value representing the entirety of the dataset. This checksum accompanies the data during transmission. When the recipient receives the data, they can create a new checksum and compare it within the original. A match between the two values indicates the data remains secure and altered. Okay. Now, limitation of hashing. Hashing serves as an initial tool in a cybersecurity. However, it is important to acknowledge its limitation. Okay, this section will provide an overview of the challenges and throwback associated with hashing in the context of cybersecurity. Okay, first, collision. A collision occurs when two or more different input produce the same hash value. Okay, it is a, it is a significant concern for large organizations that handle the vast amount of data, as they need to implement a strategy to avoid such a collisions. Okay, for instance, a company might use a chaining method where duplicate value are stored in a linked list within the hash table. Okay, performance. Hashing required a careful balance Algorithm must be optimized for the both speed and memory efficiently while also accommodating the volume of the data that the organization need to process. It adds a layer of complexity to the design and evaluation of these algorithms. In terms of the cybersecurity, a slow algorithm or one that experiences significant delay can lead to increased risk. Okay, now security risk. Hashing is fundamentally a one way process that transforms data into a unreadable string of characters. Typically, it is not possible to revert the hash value back to the its origin data. However, some advanced attacker may be able to uncover or guess the hash function, enabling them to reverse engineer the hash value or manipulate the dataset by generating fraudulent input. Thank you for watching this video. If you like this video, please like, share and subscribe to our channel for more awesome video. We look forward to seeing you in our next video.